um, fluid mechanics theory. Density or mass density. It is defined as the mass per unit volume. Liquid at a standard temperature and pressure. అయితే డెన్సిటీని కేజీ ఫర్ మీటర్ క్యూబ్లో చూపిస్తాం. రో ఈజ్ ఈక్వల్ ఎం బై బి, మాస్ పర్ వాల్యూమ్. నెక్స్ట్ వెయిట్ డెన్సిటీ ఆర్ స్పెసిఫిక్ వెయిట్. వెయిట్ డెన్సిటీ అన్నా స్పెసిఫిక్ వెయిట్ అన్నా ఒకటే. వెయిట్ పర్ యూనిట్ వాల్యూమ్, temperature and pressure expressed kilonewton per meter cube or Newton per meter cube. So or Newton per millimeter square. The weight density specific weight W is equal to rho g. For water W equal 9.81 kilonewton per meter cube equal 9.81 into 10 power of cube n per meter cube. 9.81 into 10 power of minus 6 n millimeter cube. Specific value. It is defined volume per unit mass liquid. Specific weight V small v is equal to capital V by m. దీన్ని 1 by rho రాసుకోవచ్చు. అదేవిధంగా స్పెసిఫిక్ గ్రావిటీ వచ్చేసి ద స్పెసిఫిక్ వెయిట్ ఆఫ్ ఏ లిక్విడ్, ద స్పెసిఫిక్ వెయిట్ ఆఫ్ ఏ ప్యూర్ వాటర్ సబ్స్టెన్స్. స్టాండర్డ్ టెంపరేచర్ ఎంత 4 degrees సెంటిగ్రేడ్స్ ఉంటుంది. హ్యాస్ నో యూనిట్స్. ద స్పెసిఫిక్ గ్రావిటీ ఆఫ్ ఏ ప్యూర్ వాటర్ ఇస్ టేకెన్ యాజ్ ఏ యూనిటీ. నెక్స్ట్ ప్రాపర్టీస్ ఆఫ్ లిక్విడ్స్. విస్కాసిటీ. It is also known as absolute viscosity or dynamic viscosity. Defined as the property of liquid which offers resistance to the movement one layer of a liquid over another adjacent layer of a liquid. The velocity liquid due to the cohesion and interaction between the particles. Kinematic viscosity. It is defined as the ratio of dynamic viscosity. It is density. Dynamic viscosity. Density of liquid. This is the ratio of dynamic viscosity, the density of liquid. And compressibility వచ్చేసి liquid undergoes by volume with change in pressure. The compressibility reciprocal of bulk modulus elasticity, which defined as the ratio of compressive stress and volumetric strain. Compressibility value. Surface tension. Property of liquid which enables the tensile stress expressed Newton per meter square. Surface tension is Newton per meter. The capillary is defined in phenomenon. Liquid surface is a small vertical tube held in a liquid relative general level of liquid. Height rise fall in the tube is given by H equal 4 sigma cos alpha by WD. Pressure of a liquid. Bottom of the vessel. The force all points on the sides of the bottom of the pressure for force unit area is called intensity of pressure. P is equal to P by A. Next, intensity of pressure P is equal to WH. Intensity of pressure P is equal to W, P is equal to WH. అదేవిధంగా the intensity of pressure may be expressed in Newton per meter square, Newton per millimeter square. Meters of a liquid, mm of liquid is also expressed in Pascal. 1 Pascal is equal to 1 Newton per meter square, 1 kilo Pascal is equal to 1 kilo Newton per meter square, 1 mn by m square, 1 n by mm square. Pascal's law. According to Pascal's law, intensity of pressure at any point of a liquid rests in a same in all directions: atmospheric pressure, gauge pressure, and absolute pressure. Atmospheric air is the surface at which contact the pressure sea level. Standard value for standard atmospheric pressure 101.3 kilonewton by meter square or kilopascal. 1 kilo 10.3 meters of water, 760 mm of Hg. Next, absolute pressure equal atmospheric pressure plus gauge pressure. Absolute pressure equal atmospheric pressure minus negative gauge pressure and vacuum pressure. The moment of pressure, total pressure, center of pressure. Horizontally immersed surface, the total pressure horizontally immersed surface P is equal to WAX. Vertical immersed pressure surface, the total pressure of vertical immersed surface is equal to WAX. And the depth of central pressure from the liquid surface H equal to Ig by Ax plus X. Inclined immersed surface P is equal to WAX. Depth of center of pressure from liquid surface H equal to Ig sin square theta by Ax plus X. The curved immersed surface is the P is equal to PH square plus BV square. The direction of resultant force curved surface with the horizontal given tan theta PV by PH or theta is equal to tan inverse of PV by PH. Next, this is the log gates. Log gates relation between two gates are there. The log gates provided navigation chamber, change water level, canal or river for navigation. There are two sets of gates, either the chamber in log gate. R is equal to P by 2 sin alpha. Buoyancy. When body is immersed wholly partially liquid, lifted a force equal to weight of the liquid displayed by the body. The statement is known as Archimedes principle. And the tendency of liquid uplift immersed body. The point out through which buoyant force is supposed to act is known as center of buoyancy. Okay. Next, equilibrium floating bodies: stable equilibrium, unstable equilibrium, neutral equilibrium. A floating body return back its original position is the stable equilibrium. The floating body does not return back to the unstable equilibrium. The floating body occupies a new position and remains rest in new position is called a neutral equilibrium. Metacentric and metaheight. GM equal 1 by V minus BG equal BM minus BG. అదేవిధంగా ఇక్కడ చూడు ఒకసారి చాలా ఇంపార్టెంట్ కేసెస్. స్టేబుల్ వచ్చేసి ఫ్లోటింగ్ బాడీలో M లైస్ ఎబోవ్ G, సబ్మర్జ్డ్ బాడీలో B లైస్ ఎబోవ్ G. అన్స్టేబుల్ వచ్చేసి M లైస్ బిలో G, B లైస్ బిలో G. న్యూట్రల్ వచ్చేసి M and G coincides, B and G coincides. Time oscillation floating body is given T is equal to 2 by root of K square by Hg. Fluid kinematics అంటే study of velocity and acceleration fluid by without taking in consideration any force or energy. Rate of discharge Q is equal to AV. Q is rate of discharge meter cube per second. Q is equal to AV. The velocity of liquid maximum at the center of pipe and minimum near the walls 1 meter cube equal 1000 liters. Equation of continuity Q is equal to A1 V1 equal to A2 V2 equal A3 V3. Equation of incompressible liquid continuously flowing through a pipe channel section. Type of flows in a pipe: uniform flow, non-uniform flow, streamline flow. Section open channel, same velocities. Channel have different velocities. Individual particles do not cross the each particle. Turbulent flow, steady flow, unsteady flow, compressible flow, incompressible flow, rotational flow, irrotational flow, one-dimensional flow, two-dimensional flow, three-dimensional flow. Turbulent flow అంటే ఏంటంటే does not have different path of individual particles also each other is called turbulent flow. Steady flow, liquid per second constant called steady flow. Quantity flowing per second not quantity is called unsteady flow. Compressible flow, density changes the flow called compressible flow. Dynamic fluid V square by 2Z. The total energy, total head of liquid particles motion is here. Total energy is equal to potential energy plus kinetic energy plus energy. H is equal to potential energy plus kinetic energy plus head. Bernoulli's equation. Incompressible fluid stream, total V1 plus V1 square by 2G plus V1 by W equal to Z2 plus V2 square by 2G plus V2 by W. The Bernoulli's equation applied venturi meter, orifice meter, pitot to Bernoulli's equation for real fluids V1 by W plus V1 square by 2G plus Z1 equal to P2 by W plus V2 square V1 square by 2G plus Z2 plus H1. Euler's equation. Euler's equation of motion dP by rho plus G into dx plus VdV equal to 0. The Bernoulli's equation obtained by integrating the above Euler's equation. Venturi meter వచ్చేసి higher than that of outlet. This is the Q is the discharge to venturi meter portion. The velocity and pressure liquid flowing through a divergent portion decreases. The discharge through a venturi meter is given Q is equal to CD A1 V2 by root of A1 minus Q root of 2GH. Orifice meter pitot tube ఈ విధంగా వస్తుంది. Orifice meter devices measuring the discharge of liquid flowing through pipe. With a small open tube, right angles, we measure the velocity at the liquid pipe, determine measuring the rise of liquid tube. Moment of equation. Principle of equations. This is the pitot tube. F equal dmv by dt. The impulse momentum equation given by F into dt equal d into mv. Orifice is the coefficient of concentration. It is the coefficient of velocity, coefficient of discharge, coefficient of resistance. As coefficient of velocity determined experimentally using the following relation. Coefficient of velocity CV is equal to root of x square by 4 by h. Important expression of orifices and mouthpiece. A discharge through a large rectangular orifice Q equal 2 by 3 CDB root of 2G H2 of 3 by 2 minus H1 of 3 by 2. point of streamline parallel called Werner contractional area. The when less than that of orifice, theoretically velocity at the jet of when a contract is Vh equal to root of 2gh. The expression Torricelli's theorem. This expression is called a Torricelli's theorem. Discharge through a whole submerged orifice Q is equal to CD into B into H2 minus H1 root of 2gh. Time required empty the tank complete through an orifice to the bottom. T equal to A root of H1 CD A root of 2G. Time required to empty hemispherical tank through a orifice to the bottom. T is equal to 14 pi r for 4 by 2 50 CD into A root 2G. Discharge through external mouthpiece Q is equal to 0.855 A root of 2GH. Discharge through internal mouthpiece when it's running free Q is equal to 0.5 A root of 2GH. Discharge through an internal mouthpiece in the running full Q is equal to 0.707 A root of 2GH. The re-entertain of Boda's mouthpieces in an internal mouthpiece. The jetlick concentration does not mouthpiece running free in case the mouthpiece is equal to diameter of the orifice. Notches and weights. Important expressions in notches and weights. Discharge over a rectangular notch where is the Q is equal to 2 by 3 CD into B root 2G H of 3 by 3. For 3 by 3. Discharge over a triangular notch of unit Q is equal to 8 by 15 CD root of 2G tan of tan theta by H of 5 by 2. For right angle V notch theta equal to 90 degrees. Rectangular notch where discharge over rectangular where according to Francis formula is given by Q is equal to 2 by 3 CD L minus 0.1 NH root of 2G H of 3 by 2. Maximum discharge over a broad crested where Q max equal 1.71 CD LH 3 by 2. A ware is said to be broadcasted where the way more than the heat of the water is pipes and channels. The loss head due to friction. HF is equal to loss of head due to friction in a pipe. HF is equal to 4FL V square by 2 CD. The major loss of head or energy due to friction. Minor loss head includes in following: loss of head due to sudden enlargement H equal to V1 minus V2 square by 2G. Loss of head due to sudden contraction HC V2 square by 2G 1 by CC minus 1 whole square. Loss of head in inlet of pipe H1 is equal to 0.5 into V square by 2G. Loss of head at the outlet of a piece H0 equal to V square by 2G. Hydraulic gradient in total energy lines velocity head V square by 2G. This is the pressure head T by W. The pipes in a series compound pipes different water level 2 tanks are there. H equal 4F1 L1 V square by 2GD plus 4FL V2 V square by 2GD2 4F3 L3 V square by 2GD3. F1 equal F2 equal F3 by F. H equal 4F by 2Z L1 V1 square by T1 plus L2 V2 square by T2 plus L3 V3 square by T3. A compound pipe is replaced by uniform diameter. Now both pipes are uniform diameter equivalent manner 1 by d power of 5 L1 by d1 voltage L2 d2 over 5 L3 d1. Length of equivalent by L1 plus L2 plus L. Pipes in a parallel Q is equal to Q1 plus Q2. Loss of head each pipe is same. H1 4F H1 H1 4FL V1 square by 2GD1 and 4FL V2 square by 2GD. A Simpson's rule. The Simpson's long bent pipe used to connect two reservoirs different interval ridge. The point of Simpsons is called summit. Air vessels provided at the power transmitted through a pipe. Power transmitted through a pipe. Weight of water flowing Newton per second into head of water inlet. The maximum efficiency of transmission through pipe 66.67%. Flow through nozzle at the end of pipe. Flow through nozzle end of the pipe. D is equal to d power of 5 by 8 FL 1 by 5. Water hammer known as water hammer water blow. Flow through a open channel. V according to Chi's formula mean velocity of liquid V equals C root of Mi. Q is equal to AV AC root of Mi. Hydraulic depth is the area of flow by weighted. Ti is equal to HO by L. Loss of head of unit length of according to meaning formula discharge through a open channel Q equal to AM 2 by 3 I of 1 by 2 Manning constant. Angle sloping angle ఫోర్స్డ్ వర్టెక్స్, ఫ్రీ వర్టెక్స్, అదేవిధంగా rotating P is equal pi W square R square by 4 is the total pressure top close cylinder completely requires specific weight of loading vertical axis given by the increasing pressure outer edge of drum radius filled up liquid mass density rating W number rho square R square by 2 viscous fluid 1 point is equal to 0.1 Newton second meter square 1 stroke 1 centimeter square per second 10 power minus 4 square by S. Newton's law of viscosity విధంగా వచ్చి ఓకే ఇంపార్టెంట్ ఇక్కడ. The ratio of inertia force Reynolds number the flow of pipe laminar when Reynolds number is less than 2000 flow turbulent, when Reynolds number is more than 2800 is the Reynolds number 2000 flow rather laminar not turbulent. The velocity corresponding to Reynolds number in 2000 is called as lower critical velocity and velocity corresponding to Reynolds number in 2008 is called as higher critical velocity. The loss of head due to viscosity for laminar flow pipe, the HL equal to 32 mu VL by WD square. The loss of head due to friction pipe uniform diameter which viscous flow taking place is 16 by R and R is Reynolds number. Viscous resistance is a torque required to overcome viscous resistance footstep bearing is the T is equal pi square mu NR over 4 by 60T. Torque required to overcome viscous resistance in collar bearing is T is equal to pi square mu n 60T by Ry minus R2 whole square. The quotient of viscosity according to method or fish type viscometer. Viscometer M is equal to 0.0022 T minus 1.8 by T into specific gravity of liquid. Compressible flow of fluid Q equal to A1 V1 equal to A2 V2 is M1 equal to M2 equal to velocity sound wave. The velocity sound fluid given by C is equal to K by rho. Match number and importance is the match number is less than unity, the flow is called subsonic flow. When the match number is equal to unity, the flow is called sonic flow. When the match number is between 1 and 6, the flow is called supersonic flow. When the match number is more than 6, the flow is called hypersonic flow. Stagnation point, the flow where the velocity of 0 is called stagnation flow. Where the velocity of liquid fluid is 0, flow around immersed bodies. According to potential gaseous relation, thickness boundary layer laminar flow delta LM Fx by root of Rnx and thickness boundary layer of turbulent flow 0.377 x by Rnx 1 power of 5. Types of gravity force, pressure force, elastic force. In the flowing Reynolds number, the ratio of inertia force to viscous force, Reynolds number, Faraday number, the ratio of inertia force, gravity force, Faraday number, Weber number, the ratio of inertia force, surface tension is Weber number, Euler's is the inertia force, pressure force, Euler's, inertia force, elastic force is the match numbers or Cartesius number. 0.1 n/meter square. The viscosity of water 20.2 degrees in centipoise in the air 0.17 centipoise. 1 centipoise is the 1 by 100 poise. Kinematic viscosity, the shear stress is the mu into du by dx. Du by dx is the velocity gradient of shear. Newtonian fluid shear stress A into du by dx whole power of n plus b. This is the surface tension. Surface tension of water 74.16 dyne per centimeter at 0 degree centigrade, 71.32 at 20 degree centigrade, 60.7 at 90 degree centigrade. The phenomenon rising of water, tube smaller dipped water capillarity of water. The maybe capillary rise the calculated H is equal 4 sigma cos alpha by WD. The pressure difference between inside and outside liquid drop. D is 4 sigma by D between jet of dia, D unit length 2 sigma by D for soap bubble delta P 8 sigma by D. The force for excited water on this bottom constant is called water pressure. P is equal to WH. According to Pascal's law, intensity of pressure at any point in the rest in all directions, the compressibility liquid is expressed by the bulk modulus of velocity which is equal to dB by dV by dt. Capillary attraction. Gauge pressure. Absolute pressure equal to atmospheric pressure by gauge pressure. Local atmospheric pressure measured by a mercury barometer and aneroid barometer. The difference manometer shown in the HA minus HB, H1 S1 plus H2 S2 plus H3 S3. vapor pressure, cavitation, Pascal's law, variation static pressure, dP by dV, the depth H is equal to WH, hydrostatic pressure force, and the location of pressure in case of vertical immersed plane surface given Ig by Y into A plus Iy. The center of pressure in inclined immersed plane surface Iyp को Ig sin square by Ay plus by Ix by Xy plus X, Ix minus X. For horizontal surface F equal to WHA, force on a vertical surface F equal 1 by 2 WHA, depth of center pressure from free surface 2 by 3H. Buoyant force is the metacenter. M is above body stable, swinging body. Metacenter 1 by V minus distance between center of gravity of buoyancy. Force to vortex motion V into R. Depression liquid force to vortex W square R square by 2Z. The volume of water which flows through a section of channel pipe per second is known as a discharge. The path followed by fluid particles in motion is called as path line. This is the uniform flow, steady flow, unsteady flow. Here Reynolds number dV by rho. A critical Reynolds number 2000 flow starts changing from laminar to turbulent. Rate energy in a pipe flow varies suction in the Reynolds number under 3.0. According to quantity equation, Q equal to A flow, AQ equal to AV, A1 V1 equal to A2 V2. Bernoulli's equation V square by 2G plus P1 by rho G plus H1, V2 square 2 by 2G plus P2 by root 2 plus J. According to Darcy Weisbach formula, HF equal to F of L by D V square by 2G. H is equal to total head is the H equal to Z plus V square by 2G plus P by meter liquid. The sum of potential head, kinetic head, pressure head, liquid vertical is called as total head. H is equal to Z plus V square by 2G plus P by W meters of liquid. According to Bernoulli's theorem, incompressible fluid flowing continuous flow, total energy particles, while particles moves one another direction, Z plus V square by 2G plus rho W. Discharge in a pipe in a diameter either intersection venturi meter and orifice meter. Discharge through venturi meter. Q equals CD, A2 V2 equals CD into root of 2GH, A1 V2 by root of A1 square minus A2 square. Pitot tube is in metacenter velocity of fluid in a pipe or channel V equals CV root of 2GH. In the orifice 2 to 3 times diameter in length. Various hydraulic coefficient are coefficient of contraction. It is the average value of taken as 0.64. Coefficient of velocity is the average value of taken 0.97, and the head of coordinates when a constant CV equals H by 4 by H. Coefficient of discharge is its average value taken 0.62. Coefficient of resistance treated as 0 for all particles. Laminar flow laminar untadi. Viscosity dV by dy, mu into dV by dy. Dynamic viscosity by density. Dynamic viscosity m L minus 1 T minus 2. Dynamic viscosity L2 T minus 1 meter per second. Viscosity of water, room temperature, mu is equal to 10 power minus Ns minus 1 and V is equal to 10 power minus 6 m square V square is 1. Laminar flow circular pipe flow Q equal to pi P1 minus P2 R power 4 by 8 μl. Mean velocity P1 minus P2 R square by VL and velocity maximum velocity Vm equal to 2V. Laminar flow between flat plates flow V is equal to P1 minus P2 double T by W 12 μl. Mean velocity V1 minus P2 T square by 12 μl. Maximum velocity Vm equal to 3 by 2V. Q equal to pi by 8 μl P1 minus P2 R square minus R square R square plus R2 minus R square minus R square in R by 2. Mean velocity V Q by pi of R square minus R square. According to continuity equation, V1 E1 equal to V2. According to Bernoulli's equation, V1 square by 2G plus P1 by W plus Z1, V2 square by 2G plus P2 by W plus Z2 losses. M1 rho E1 E2 head loss due to pipe enlargement K V1 square minus V2 square 2G, where value of K is 0.39 for alpha is equal to 10 degrees, 1.06 for alpha equal to 40 degrees, and 1.0 30 degrees. Open channel flow, hydraulic radius, water cross-sectional area by wetted water meter perimeter, various wise notch and channel. Unsuppressed air is the flow Q is equal to 2.95 CD, B minus 0.2 H of for immersed air is the flow Q equal to 3.33, B H of 1.5. For V notch flow Q is equal to 2.36 CD, then tan theta by 2 H of 2 by 3. V is equal to root of Mi, flow rate Q is equal to Va. 87 by 1 plus K root of M, hydraulic wind radius A by B. Value of K is 0.16 to 0.28 for brick and stone surfaces and 1.30 for neutral earth. Trapezoidal section of half hexagon. The best hydraulic trapezoidal section of a half hexagon. Hydraulic jump. The observed reduction of velocity by means and increases water depth and constant pressure. Hydraulic jump spillway, essentially part of large dam, provides coefficient of means releasing for water excess design the reservoir, culvert, standing up, dimension analysis, dimension parameters, delta P by rho V square by 2, pressure by dynamic pressures, pressure force by inertial force, L by D V square by 2G or H1 by V voltage square by FL by D, Reynolds number rho V D by mu, universal force by viscous force, OD number V square by GL, V square rho A by GL, rho A dynamic force by V2, V square LP by rho inertial force by surface tension, H number V root of K by P by rho model rest. Laminar flow through a circular tube, circular annually, with 128 mu L cube by pi D power 4. Also head loss H1 equal to F of 4L by D V square by 2G. The discharge from an orifice of area head integral velocity equal to A by CD into A root of 2G root of H1 minus H2. 2A1 A2 root of H1 minus H2. A to CD into A root of D notch. For over rectangular where notch length L, depth H Q equal to 2 by 3 CD root of 2G L H of 3 by 2. In triangular where notch semi-angle Q equal 8 by 15 CD root of 2G tan of theta H of 5 by 2. Error discharge measurement for a H rectangle triangular notch where dq by Q 3 by 2 dH by H and 5 by 2 dH by H respectively. Flow over broadcasted where length L, water depth over before Q is 1.7 CD L H of 3 by 2. Hydraulic gradient, hydraulic slope, head loss due to friction by total length of pipe. Hydraulic mean depth is the area of crossing total length of pipe. According to Darcy equation, H of equal to FPL by A, V square by 2G for pipe into H of 4FL by D, V square by 2G. According to this formula, V is equal to root of Mi. The losses between the pipes, loss to the entrance 0.5 V square by 2G, loss of the outlet V square by 2G, loss due to friction 4FL V square 2G, total loss of the head in a pipe 0.5 V square by 2G plus V square by 2G plus 4FL V square by 2CD. The maximum power transmitted, the nozzle, the loss due to friction should be 1/3 of supply head. 1/3 of supply head. For maximum power transmission by a nozzle diameter D obtained from the formula, D is equal to D power of 5 8FL by 1 by 4. Again, maximum power transmission nozzle, the ratio of pipe area nozzle is rated 8 by F, A root of 8 if FL by D. Total head loss FQ square by 3. For laminar flow circular pipe, pi R over by 8 by Py minus P2 by L. Water hammer, rise in pressure, sudden sloping flow is the pipe. P is equal to V by root of G by W 1 by K plus D by TE. Surge tank used to relieve pipeline excessive pressure. Flow in a pipes circuit. The algebraic sum of pressure drops around each circuit must be 0. Flow pipe is the delta P1 of 1 minus 8 FL by 2G D delta mass flow P1 V1 pi of D square by 4 P rho 1 BT V1 pi of D square by 4. Flow through orifice mass flow formula ఇది ఉంటుంది. Where maximum flow when n equal to 2 by r plus gamma r by 0.52 for air, Cp by Cv, and drag D is equal to CD A rho V square by 2 velocity sound in a gas, V is equal to P by rho equal to T. Match number M is equal to V by Vs. Acceleration, two-dimensional flow, radial acceleration, potential acceleration, boundary layer flow. U equal 0.99 U sigma, y equal d, displacement thickness 1 minus U by U infinity dy, momentum thickness U by U infinity 1 minus U by U infinity dy, 0 to delta. Relation between the free thickness delta equal 3d 7.5 t. 0 to U by U infinity 1 minus U square by U infinity square dy. Loss of energy per unit time here 1 by 2 P to d. Laminar boundary delta is 5 by root of Rex, where Rex is less than 5 into 10 power of 5. Turbulent boundary layer delta by 0.37 by Rex of 1 by 5. Diagram ఇది ఫార్ములా ఇది ప్రెజర్ డిస్ట్రిబ్యూషన్ ఇట్లుంటుంది. లామినార్ ఫ్లో వెలాసిటీ ప్రొఫైల్ u మైనస్ 1/4 mu dp by dx r square మైనస్ r square. u max వచ్చేసి మైనస్ 1/4 dp by dx r square. స్టడీ ఫ్లో టు సర్క్యులర్ ఫ్లో రేట్ అంటే పై డి పవర్ ఆఫ్ 4 డెల్టా పీ బై 128 మ్యూ ఎల్. హెచ్ పాయిసన్స్ ఈక్వేషన్ 1/8 మ్యూ మైనస్ డిపి బై డిఎక్స్. పైప్ వాల్ డిపి బై ఎల్ r1 స్క్వేర్ బై ఎవర్ వెలాసిటీ త్రూ పైప్ క్యూ బై పై ఆర్ స్క్వేర్ డిపి బై r1 స్క్వేర్. ప్రెషర్ డ్రాప్ 32 మ్యూ విఎల్ బై డి స్క్వేర్. 64 ఆర్ ఎనర్జీ లాస్ బై 32 వి రో జీ డి స్క్వేర్. 64 ఆర్ ఈ బై head loss v square 1 by d v square by 2z fraction 64 by r. Reynolds number v vd by v. Stokes law terminal velocity v equal to d square by 18 mu ws minus wl. F equal to 3 pi mu vd. Drag and lift is the pressure drag of dp divided up to da. Drag coefficient cd of d by 1 by 2 mu v square da. Lift coefficient CFL by 1 by 2 rho mu square a. Boundary layer thickness fx 5x by root of rex at u by unit 0.992. Displacement thickness delta 1.73 x by root of rex. Momentum thickness 0.664 x root of rex. Local wall shear 0.332 by root of rex rho of u square rex ux by v. Friction drag coefficient local component by 1 by 2 rho u square 0.664 by root of rex. Friction drag on side length FD by 0.664 rho u square root of VL by root a. Average friction drag coefficient CFFDB 1 by 2 rho u square 1.324 root of REX where REL UEL LV. Turbulent boundary layer smooth flat plate bed. This is the REL less than 10 degrees from average velocity V equal 0.817 U max 0.2817. Boundary layer thickness delta 0.379 x by rex of 1 by 5 less than x of 4 by 5. Local skin fraction coefficient CF 0.059 by rex 1 by 5. Friction drag per unit width to one side of plate length 0.0368 L0 area of minus 1 by 4. Average coefficient of friction drag 0.07 for RELX of 5 into 10 power of REL. ఈ విధంగా ఉంటుంది. ఈ విధంగా ఉంటుంది లాస్ట్ ప్లేస్ స్పియర్ యాజ్ పర్ సెట్ కోఆర్డినేట్స్ ఇట్లా ఉంటుంది. వెళ్ళిపోతున్నాం. Certain coordinate 1 by alpha dt by dou t dou square t by dou x square cylindrical radius 1 by dt d square t by dou r square plus 1 by dt. Spherical coordinates 1 by d square t by dou square plus 2 by r 2t by dou r. Thank you. FM is over theory.